All right, so in this video, we're going to look at another differential equation and applying some initial conditions just so we can take care of all the little mathematical ideas that could come up here. So again, it's a second order, homogeneous, linear differential equation, constant coefficients. So we know that the assumption is that y is equal to e to the lambda t, which means that this differential equation boils down to this characteristic equation. And we have the good fortune of this one factoring. So that means this is lambda plus 3, lambda plus 2 equals 0, which means lambda is negative 3 or negative 2, which means that my general solution is y equals c1 e to the negative 3t plus c2 e to the negative 2t. So something times e to the negative 3t plus something times e to the negative 2t. So now at this point, we want to find C1 and C2 so that these initial conditions are satisfied. So y at 0 is going to be C1 e to the 0 plus C2 e to the 0, and we want that to be 1. Now naturally, I'm going to write that in a simpler form as C1 plus C2 equals 1. So that's one condition on C1 and C2 that I know. In order to find in order to find both C1 and C2, I need another equation. And that's going to come in from my first derivative. So we'll find y prime first. And we know that y prime is equal to negative 3c1 e to the negative 3t minus 2c2 e to the negative 2t. And now when I plug in 0 to the derivative, which is negative 3c1 e to the 0, minus 2c2 e to the 0, I'm supposed to get 2. So that means, in short, negative 3c1 minus 2c2 is equal to 2. So there's my second equation involving c1 and c2. So now at this point, what we have to do is figure out the best way to solve c1 for c1 and c2. So I could see elimination working, I could see substitution working. I'm a fan of elimination or the addition method. So actually, I'm going to take this equation out of the box here, and I'm going to combine this with C1 plus C2 equals 1. And it looks like I'm going to be multiplying the second equation by 2. And that's going to make the C2s go away. So if I do that, they're all just 2's. See what I did there? So adding those equations together, these go away, and we get negative C1 is equal to 4, which means C1 is equal to negative 4. And now figuring out what C2 is, so it looks like we have negative 4 plus C2 is equal to 1. I'm using the equation C1 plus C2 equals 1 because that's easier. And then solving for C2, we get 5. So that means my actual solution is, so C1 is negative 4. So the solution was, it was up here somewhere. Here we are, put it in the box. So we have y equals negative 4 e to the negative 3t plus 5 e to the negative 2t. And that is our final solution. So as you can see, not only are we worried about solving differential equations, sometimes we have to use that old algebra. Solving systems is going to be a part of what we do. So hopefully that video helps, and stay tuned for more videos. Thanks for watching.